Hello and welcome back to another festive coding session with Mr. Jacob. Today we are on the 18th day of our Advent of Languages and we are going to implement, as always, the same thing in a different language today as we have done in the other 17 days before this on the days of December. And we are striving to implement something that in the end will resemble this ASCII at Christmas tree, sometimes with the ornaments, sometimes without, sometimes with Unicode, sometimes without. Today we will actually do some sort of retro session again, where we will take a look at my actually second programming language that I really programmed in, which was Pascal, or better said Turbo Pascal, on my first MS-DOS PC. And we already took a look at Amiga Basic, which I will link up there in the upper right corner as well as in the description below. And Turbo Pascal actually was the language where I did a lot of stuff in back in the day, and I have prepared it here already in a DOS box and installed it in version 7. I got that from the internet. As I'm not 100% sure this is not still copyrighted, so I can't put it into the repository with the code. However, I have put a README file there detailing how you can install it yourself, and you will find the packages somewhere on the internet, which I have documented as well. So if you are interested in recreating this, you will have all the information there. So let's quickly get into it. Pascal actually looks a lot like, and we will see that in a second, like Ada, actually. And I will explain in a second why this is. So a Turbo Pascal program always starts with something like a program name. And then it will start with an initial code block here, which always ends at the end of the file with the end dot, which is quite important. So the last end, the one that is actually denoting that we are ending a program here, actually always ends on a dot. That is something that I stumbled a lot upon when doing Pascal, so I remember that very clearly. And now we can do in here something like, for example, we could do write line, and we can do something like hello Xmas. And we should do something like read line in the end. And if you don't have any arguments to a function, you simply call it without the braces there. So we are simply reading a line. And we are doing that because inside of our development environment, which we have here in our DOS box, we actually can now run this program, and we will end up in this kind of prompt here. And we can see our hello Xmas here. And if I press enter, I'm back because I have read this line. If I would have actually not had that there, where I actually, by the way, comments are using curly braces in Pascal. If I did not have that there, I would simply not have seen much because it would jump back into our editor immediately. So let's have this read line at the end. I usually had this at most of all of my programs, which were not kind of creating an interactive input-based session, like, for example, this editor in the end. Okay, so as you already can see, there are some similarities with Ada. And the reason why it is that way, by the way, we had a session about Ada here as well. I will link it up in the description. Is quite simply the reason that the developer of Turbo Pascal actually was part of the team that defined the language design of the Ada language. So there was a lot of knowledge from the days of Turbo Pascal from him, which kind of influenced how Ada was in the end structured and created from a syntax standpoint of view. Even though Ada is the much more modern language, which you still can use today to write proper software, while Turbo Pascal more or less is kind of extinct because you can't do any more much with it in today's world. There was something that was kind of based on that called Delphi from Borland, which was capable of creating proper Windows software and stuff like that, but Turbo Pascal in the end is kind of dead. However, it's a nice nostalgic experiment here to get going and create this. As with Ada, there are two different ways to define a function or a procedure. There is a procedure, which is something that never returns something, but is simply called as a procedure to do something else. And there is a function which can actually return a value. And I guess first of all, we need a function. First of all, we need our procedure here. Which draws our groups as usual. So if we take a look at our tree here quickly, we want to kind of draw out those groups. So the first one, the second one, the third one, and so on, to create this zigzag shape of a tree. And in order to do that, we need something here that actually can do that. So let's maybe create a procedure. Let me get the mouse cursor out of the way. Print groups. And within these groups, we will take the number of groups here with a type of an integer. And I guess we will then simply begin our function and end our function. By the way, that is something that I stumbled upon as well when I reinvestigated this. It was that the end of those procedure declarations always need to have a semicolon before actually the body begins. And now in our print groups function, we would like to do a loop. So we would want to do something like for I in 0 to groups -1, because it's always inclusive. We want to do something and we want to then begin and end here. However, we can't just use this variable because Pascal needs to know what kind of variable that is. So we have this variable declaration blocks before our body, our function body, and all this resembles Ada as well, or you can find this structure with the context blocks in Ada as well. So what we do here now is we simply tell that the I is an integer and it should be available within this function body. And now it is available here. So we should actually be able to do something like write line. And that I'm not sure about if I can just print out an integer like that. I guess we will see in a second. Let me remove that here. Let's create for our main program a declaration body. Let's call that groups there, and let's do an integer there as well. So now that we could say, okay, we want to set, and by the way, we are always defining variables using this definition syntax with colon equals there. We want, for example, 3 groups here, and now we want to call our print groups here with the number of groups here. And let's see what actually happens when we run this code. Okay, so it seems we can print out integers using just write lines. So we now see 0, 1, 2. Perfect. So this loop is already working. However, what we need now is we need to print out the spaces before, then we need to print the spaces in between, and then we need to print out the slash and the backslash. So first of all, I guess we need to create a function for us, and in this situation we really want a function which can somehow repeat a certain character a given amount of time. So I guess we could do something like repeat char. We could define that function and it could take a character. And actually there is the character type, the char type in Turbo Pascal, so we can use that. And I guess we take the amount as an integer here, and our function in the end will return a string. And then we end that with a semicolon as well. And you might see something else here. We are delimiting different arguments to a function, not with a comma as we are doing in most other languages today, but with a semicolon. Because the idea here is kind of that it is like more or less like that. So you have those in different entries. You are wanting a function with a character and an amount, and you splitting all those up with semicolons there. So I guess we will need an iterator variable there as well. So let's quickly give us one. And then we can do a begin here and an end here. And let's put our function of for loop in between. So for from 0 to amount -1, as it is always inclusive, do, begin, end. And here we will see now that we need some sort of output where we can actually collect our string up. So let's define our output here, which would be a string, I guess. And then we can now go ahead and put into our output. We define that as output. And now we need to concatenate two strings together. And actually in Pascal, you can simply do that by just adding them together with a plus. So what we want to do is now we want to add the character to our output, the amount of times that we need it actually. And now we want to return it. And in Pascal, if you want to return a value from a function, the syntax is actually quite neat. And I've not seen anything like that in another language there, which is you simply assign to the name of the function that you are in the output value. And this is actually doing how you, or this is actually how you do a return in Turbo Pascal. You are assigning to the function name the output. So now we actually should have something like repeat char. So let's quickly check if we actually have. We will need in the end our divider line there anyways. So we will need this line down here. So let's maybe quickly print that out using our now created technique here. So we should be able to do something like write line, repeat char, and we want a minus character there, and we want it groups times 2 plus 2 times, and that should actually be our divider line though. So let's see if this actually works out. And we need a comma somewhere. Okay, where did I do something wrong? There was a comma expected. So yeah, I think I just left out a brace there, so not really a comma that was expected there. Okay, so now we have some sort of garbled up strange stuff there, which is kind of irritating to me. Let's run this again and see if this happens again. Okay, and it happens again. So we did something a little bit wrong there, maybe. So what did we do there? We had actually do it like output plus output again. We never initialized, nice, we never initialized our output here. So I guess that we need to do something like put an empty string in there at first so that we can actually get this going. And now, yeah, now it works as it should, because we simply had some garbled up stuff in this string before. Okay. So we have our repeat character thingy there now. So now I guess we can go back to our print groups here. Let me put this somewhere in the middle of the screen and write out the proper tree coding. So first of all, we need to write out the spaces. So maybe create quickly a procedure, because we will need that over and over again, calling print spaces, and it simply takes an amount, which is an integer here. And we will do a begin, and we will not need variables here. However, what we want to do is we want to write, not write line, because we don't want to go into the next line. We want to simply do repeat char, and we want a space character repeated the amount of times. And that we want to actually simply write out there. So now we can do in our print groups here, we can do print spaces, and we can give it groups minus I spaces, because that's essentially how many spaces we need in front of the first line. Then we want to write out the slash, the first slash. Then we need our inner spaces, which are actually let me think, I times 2. So we need I times 2. So the level that we are currently in times 2 amount of spaces there. And then we write out backslash. And I hope, yeah, that's on the keyboard here. That's a little bit, that's a little bit hard to find on this keyboard layout here. And we don't need to escape that, because Turbo Pascal doesn't have backslash escaping within its strings there. And what we are doing now is we can, or we should maybe just print this with a write line, so that it will automatically jump into the next line as well. So what we now need to do is we need the second part of our group, because our group, as you can see here, always consists of 2 different lines, the first one and the second one. The second one position to the left, and having the inner spacing of the level down. So in this case, we need to simply do something something like, let me get the mouse cursor out of the way, something like print spaces. And what we want here is groups minus I minus 1, because as I've said, one less. We want to write the slash there. Come on. And we want to print out the spaces. And now we want I plus 1, so essentially the spacing from the next group iteration there. And that times 2. And then we want to right line the backslash, which was here. And now we should actually have the initial part of our Christmas tree already there. So let's see if this actually runs and compiles. And as you can see, we have our Christmas tree there. Even though the DOS font isn't exactly perfect to print our Christmas tree, it's a little bit wider and kind of fluffier than all of our other trees, but it is working. So now what we need simply is we need the trunk there. So maybe let's create another procedure for that. Let's do procedure print trunk, and we give it the number of groups because we need that for the spacing, which is an integer again. And yeah, that would be it. And then we have begin and end, and we can do something like, let's see, we are simply doing print spaces because we need an amount of spaces as we have groups. That's actually how many spaces we need. And then we are doing right line, and we are putting the, is it here? No, where actually is this character here? There, 2 of those pipe symbols we put just out there, and then we go into the next line, and we actually want to do that 2 times. So maybe let's do another iteration here, or we could simply copy that. Let's maybe just repeat that then. So print spaces groups, it's easier than wrapping it into another loop there. So right line, and it was here, yes, it was there, and now we actually should be able to call that here and doing print trunk groups. Okay, so let's see if I can now run this. And now, as you can see, we have a fully finished Christmas tree there. And we can actually do that maybe a little bit bigger, like for example as a 7, and we can do run, and now we have a lot bigger Christmas tree on there. And what we can now do is, let me quickly save that on our A drive, which is mapped to something on my hard drive, of course, and I want to save it as xmas.pass just to make sure that we actually have that saved. And now I can go to compile. I can actually change the destination from memory to disk, and now I can actually click compile, and now I have actually compiled the program successfully. I can exit out here. I should be able to go to Dear A, and now I should have my Xmas executable here, which I can now simply call in DOS, and it will show this Christmas tree prompt there. And maybe we should fix up this by just going quickly back into our Turbo Pascal environment, opening up a.xmas.pass and removing this read line at the end. And of course, we could do something like reading the amount of Christmas tree elements that we want to print from the command line there and such, but let me quickly change that. But however, I guess we already have the session here long enough, because the last ones were long and I don't want to make all of them so long. So let's quickly compile that again. Let's go out of there. No, I don't want to save that. Exit. Yes. And now we go back to A again. And we have our, we should have our Xmas ASCII there. So if I call that now, as you can see, we have a neat little program of 3.5 kilobytes in size. It's actually only 3 times larger than the whole source code that we have written, which is always kind of awesome to see. However, now we have a DOS program written in Turbo Pascal, which prints out our Christmas tree. And yeah, I hope you had as much fun as I did remembering and somewhere strolling in this nostalgia path here, and taking a look at Turbo Pascal again and writing out this Christmas tree program in Turbo Pascal here. And I hope you will join me in the next sessions where we do that again in another language and another language and another language, building up to our great finale on the 24th, where we will be doing something kind of like that. We will be doing a programming exercise as well, but we will be creating not an ASCII art Christmas tree, which would be boring. We will create something a lot more physical, I would say. So yeah, I wish you a good time, and I hope to see you in the next one. Bye!